Hi everyone, good morning. So I'll just share my screen. So in yesterday's class, we have started with this linear regression, right? And we have performed the EDA. Now we need to remove the outliers. So from the box plot, we can see that we have outliers in our data. Now we have to remove the outliers. Now how to remove the outliers? We have to create a function for that. So the function is df remove underscore outlier column, sorted column. Just like we are sorting this column, let's say what this sorted will do. Let's say column is equal to, we are adding ABC, XYZ, PQR, TOV. Now, this sorted column, what it does, sorted column, it will sort the column based on the alphabetical order, right? Even though XYZ is second, but it is coming in the last, right? If you consider the sequence. Now Q1, comma Q3 is equal to np dot percentile column comma 25 comma 75, and we have IQR which is equal to Q3 minus Q1. Lower whisker is equal to Q1 minus 1.5 times of IQR, and upper whisker is equal to Q3 plus 1.5 times of IQR. And we are going to return this lower whisker and upper whisker. Q3. Now in your data frame, tf.head, you just have to restart and run all this. Now in your data, as you can see, we have to remove the few columns because the car name is a categorical column and MPG is a target variable, right? So for column, we'll drop this df.drop origin origin, then comma MPG and comma car name because it's a categorical column. We have to drop this and access equal to 1, it will be column wise operation. And if you write dot columns, this is remaining. Now we'll define lower whisker and upper whisker. We'll use the remove outlier function that we have created, and df of column. Then after this, df of column is equal to np dot where df of column is greater than upper whisker, comma upper whisker, comma df of column. Df of column is equal to np dot where df of column is less than lower whisker, comma lower whisker, comma df of column. Now, if you just plot this pnt dot figure, fixed size is equal to 20, 12, df dot box plot vertical is equal to false. Now, you can see that we do not have outliers in our data. Earlier we had outliers. Now we don't have outliers in our data. Now let us see the train test splits. So what is train test split? So suppose you have this data with you and just imagine you, let's consider train test split scenario like this. Just imagine you are preparing for UPSC exam, or there are two students, A and B, who are preparing for UPSC exam. Now, in order to prepare this, we have to give the practice exams, right? And then final exam, let's say, which is on 31st June for an exam. So A has given four practice exams, and B has given 15 practice exams. So in final exam, A might score less. So if suppose A is scoring 65 out of 100, B will score high because he has given, or he has practiced, or he has given more exams. So what is this thing? This is just a training and this is testing, right? The final exam is your testing of your knowledge. So similarly, in machine learning as well, we have training set and we have testing set. Now, what is training? What is testing? Training is used for, or used to train the data, and testing is used to test the data, or it is used to find the accuracy of your data. Training is used to train the data, testing is used to find the accuracy of your data. Now, if suppose we have 10 data points, 10, तो 10 के 10 में से 5 डेटा पॉइंट्स ही आप ट्रेनिंग को दे रहे हो और 5 डेटा पॉइंट्स टेस्टिंग को दे रहे हो, तो टेस्टिंग की एक्यूरेसी कम आएगी ऑब्वियसली, बिकॉज दोनों इसमें इक्वल है, राइट? बट ट्रेनिंग को अगर आप 8 डेटा पॉइंट्स दे रहे हो और टेस्टिंग को सिर्फ 2 दे रहे हो, तो टेस्टिंग में ट्रेनिंग को आप ऑब्वियसली ज्यादा डेटा पॉइंट्स मिले हैं यहाँ पे, तो ट्रेनिंग एक्यूरेसी विल बी और दी एक्यूरेसी विल बी हाई, बिकॉज ट्रेनिंग में आपको ज्यादा डेटा पॉइंट्स है ना. यू कैन कंपेयर विद दिस एग्जांपल. इन ट्रेनिंग फॉर बी यू हैव गिवन मैक्सिमम ट्रेनिंग, सो उसकी एक्यूरेसी ज्यादा आ रही है. सिमिलरली मैक्सिमम ट्रेनिंग आपको मशीन लर्निंग मॉडल को दे रहे हो आप, तो उसकी एक्यूरेसी भी ज्यादा आएगी, राइट? सो वी डिवाइड योर डेटा इन सच ए वे दैट एक होता है आपका ट्रेनिंग सेट और एक होता है टेस्टिंग सेट. ट्रेनिंग सेट में क्या होता है कि एज यू कैन सी कि ज्यादा डेटा पॉइंट्स आपको ट्रेनिंग में दिए है और ट्रेनिंग सेट में ट्रेन करते हैं डेटा, एंड वी फर्दर हैव वन मोर स्प्लिट विच इज एक्स एंड वाई. तो मशीन लर्निंग में यही दिस इज व्हाट वी डू. our data we divide into x and y. x में क्या होता है, we have all the independent variables और y में we have only target variable, right? In x you have all the independent variable, in y you have the target variable. Is it clear now? What is x, what is y, what is train, what is test? So this will be x train, this will be x test, this will be y train, and this will be y test. Is it clear for everyone now? Do you have any questions in this? So this is what we do. Now in order to perform trend test split, we have to call a package. So how to get the package? You just write down trend test split package name, and all you have to do is you have to go to the scikit-learn official website. And over here, if you just search this, and if you copy this, you'll be able to get this, right? Now x is equal to df dot drop. x में क्या रहता है? x में all the independent variable. तो mpg target variable है और car name is your, what is car name? It is a target categorical variable. So you cannot fit the categorical variable और इसको encoding भी करने की जरूरत नहीं, because if you just see कि car name कितने हैं आपके पास, value counts. So it will be 305 car name है आपके पास, 305. तो 305 के लिए it is not necessary to go for encoding, right? So we'll drop this, comma, access is equal to 1. And if you run this, then if you calculate the head of your data, तो ये हो गया आपका इंडिपेंडेंट वेरिएबल. x में आपके सारे इंडिपेंडेंट वेरिएबल्स रहते हैं. In y what do you have? In y you have target variable. In y you will be having target variable. So if you check y, this is your target variable. Is it clear now, everyone? Now we'll go with the trend test split. So trend test split जो करने का टेक्निक है, that is common for all the machine learning model. It is common for all the machine learning models. You just have to remember this thing. How we do is we go with the x underscore train, comma x underscore test, comma y underscore train, comma y underscore test is equal to train underscore test underscore split x comma y comma test underscore size is equal to 0.3. Random state, we'll see what is random state. So let us don't give random state. Yeah, anybody have any questions? So ऐसे आप ट्रेंड टेस्ट स्प्लिट करते हो, x train, x test, y train, y test, ट्रेंड टेस्ट स्प्लिट इज योर पैकेज x y एंड टेस्ट साइज 0.3। मतलब क्या हो रहा है कि ट्रेनिंग और टेस्टिंग किस में डिवाइड हो रहा है, ट्रेनिंग का साइज है 70% ऑफ योर डेटा, टेस्टिंग का साइज है 30% ऑफ योर डेटा, राइट? Yes, anybody have any questions in this? Now we'll check the shape, df dot shape, x underscore train dot shape, x underscore test dot shape. Now you'll see that over here we have 398 shape of your data frame, right? 398 is the shape of the data. So what is 70% of that 398? 278.59. So 278 मतलब 70% डेटा आपका ट्रेनिंग में और 30% आपका डेटा किसमें, टेस्टिंग में. If you can check this 0.3 of 598, 398, sorry. So 119.39 is your part of your testing data. Is it clear now, everyone? So यहाँ पे 70-30 split हुआ है. Generally 70-30 करते हैं. We go with 80-20 as well, or we go with 90-10 as well sometimes. 0.6 भी होता है कभी कभी, but इसके नीचे we don't go, right? Now once this is done, we'll go for model building part. तो ये हो गया आपका EDA. और मॉडल बिल्डिंग के भी 4 स्टेप्स कॉमन है सबके. व्हाट इज द फर्स्ट स्टेप? फर्स्ट स्टेप इज ऑब्जेक्ट creation. Second step is model fitting. Third step is model prediction. And fourth is model evaluation. Then we'll write down object creation. Model is equal to, right, we have to call, this is your linear regression, right? So we need to call linear regression package. So this is our linear regression package. We'll call it over here. And object creation, step 1. How we create the object is model is equal to linear regression. What is the step 2? Model fitting. Model dot fit. We fit it on x underscore train and y underscore train. So remember, यहाँ पे object, you can give any name over there. You can give ABC, you can give your name, but generally this is our common method. We write down model. is equal to this. Then remember this, we always fit, we always use xtrain and ytrain to fit the model. We always use xtrain and ytrain to fit the model. What is our step 3? Model prediction. So y underscore pred is equal to model dot predict x underscore test, right? And what is step 4? So in this also, remember we always use x underscore test to predict the model. Now what is step 4? It is model evaluation. तो ये जो मॉडल प्रेडिक्ट किया है, मॉडल बनाया है, उसका एक्यूरेसी क्या है, उसका परफॉर्मेंस क्या है, वो ये स्टेप 4 में we generally check. So that is known as model evaluation. In model evaluation, we have evaluation metrics, just like your R2 score, accuracy, right? So ये evaluation metrics आपके regression के लिए अलग है. We have अलग different regression evaluation metrics. We have different classification evaluation metrics. So evaluation, model evaluation, what do you have is, you can, let's use R2 score. Now what is the package for that? We have to copy this and we have to paste it over here. Got R2 score. Yeah. So how to check the R2 score? You write down the package R2 score of Y test and Y pre. So it's 84. So accuracy कितना है आपका? 84.2% for your model. तो ये step है आपका for model building. First is object creation, then model fitting, then model prediction, then model evaluation, then you perform like this, right? Now, if I restart and run all this, I'll get different accuracy. I'll get the different accuracy for each iteration. देखो अभी 82.62 आ रही है. फर्स्ट कितने आ रही थी? 84. Now second iteration it is 82.62. Third iteration, let's restart and run all this. Third इसमें 83.41 आ रही है. 83.41. So I don't want this, right? Every time I should have the same accuracy. So उसके लिए है, we have random state as a parameter. You can give any value, literally any value. Let's give 3 suppose. Now if I use random state 3, I'm getting 82.62, right? So I'll just restart and run all this. and I'll check if I am getting the different accuracy or not. Same RE, right? Let's try it one more time. So it is same, right? Now how to, like, what is the random set? We'll try to understand this. So random state is, suppose this is your data, right? You have 1, 2, 3, 4, 5 and 6 data points. So random state क्या है कि it is a fix. Suppose if I use random state 1, तो ट्रेनिंग में आपके सपोज ये डेटा ट्रेनिंग के, सो आई जस्ट कॉपी दिस, आई पेस्ट ओवर हियर. तो ट्रेनिंग में आपके सपोज ये डेटा है और टेस्टिंग के ये डेटा है, राइट? फॉर एन एग्जांपल, तो ये फर्स्ट 4 डेटा पॉइंट ही ट्रेनिंग के रहेंगे, वो फिक्स रहेगा रैंडम स्टेट, और ये 5 6 टेस्ट के रहेंगे. सो आपको एक एक्यूरेसी मिलेगी, सपोज 82.62 मिल रही है, तो ये एक्यूरेसी फिक्स रहेगी. लेट्स से यू आर यूजिंग रैंडम स्टेट इज इक्वल टू 2. सो दिस टाइम व्हाट इज हैपनिंग इज अलग कॉम्बिनेशन बनेगा. लेट्स से ये आपके ट्रेनिंग के है, दिस इज योर ट्रेनिंग डेटा and this is your testing data. Now let us go and take this thing, random state is equal to 3. Now this time let's consider this 4 as your training and this 2 is your testing data, right? So if you just go and change the random state value, अभी random state 3 के लिए ये value आ रही है, right? Accuracy की. Let's go and change the random state. Let's write down 7 over there and let's restart and run all this. So random state 7 के लिए कितने आ रही है? It is 77.20, right? So हर एक random state के लिए अलग accuracy रहेगी, right? Now in this data, the data that we had, the accuracy is the data point size is 398, right? So ऐसे अलग अलग combination बनेंगे 398 और depending upon the data set. So that is the reason random state का कुछ size नहीं, मतलब restriction नहीं है कि we have only 40 random state or 50. You can give any value over there. That is not the case. Now is it clear for you what is random state? Everyone, is it clear? So if this is clear, we now you'll ask these questions. Suppose now how to find the best value of random state then. So it is not like this. You can use any random set value of your choice, but we have different techniques to increase the accuracy. We have different technique to increase the accuracy of the model. So accuracy कैसे increase करते हैं उसके लिए अलग टेक्निक है. रैंडम स्टेट एक ही बार देना है आपको और उसके बाद में you don't have to try it. So you can give any value 3, 4, 5, 6, 7 and just check whether your accuracy is increasing or not. But accuracy increase करने के लिए we have different techniques. So this sums up your model building. This is how you build the model. Now, if you have any questions, you can ask, or if it is clear or not, you can let me know in the by using the this thing reaction. You have any questions? Yes. Do you have any questions in this? So this is what we have. I'll just share. Linear regression is done. Let us check if we have something more for this or not. Right. So we have covered this Best fit line regression thing. Goal of any linear regression algorithm is to fit the line. Then this is our error that we have discussed. Now, what is cost function? We might have not discussed this. Let us discuss this. What is cost function or what is gradient descent algorithm? So, let us check it over here. And so, actually, am I audible, guys? You can let me know in the chat. So I'm on mobile connection right now. So you might be having some lag in the voice. Just let me know at that point itself if my voice is breaking or not, right? So is it fine now? All right. So if you take the square of this residual term and then if you add, just if you write down sum of this, और let's say average, because we are taking mean squared error, right? तो square तो ये हो गया, और इसका mean कैसे लेते हैं? Obviously summation and divided by total number of points, right? तो 14.33 is your mean squared error, right? So ये जो है mean squared error first initial इसमें 14.33 आ रहा है, right? So हमेशा first it will be maximum only, then we'll go with the next this thing, next diagram or next line like this. तो ये suppose ये second line है, ये third line है. Second line का mean squared error कम आएगा because we are trying to modify that, right? So it will be over here suppose. Third इसका suppose आ रहा है और कम, तो it will be here. And what is our best fit line? Best fit line का mean squared error क्या रहेगा? Cost function for an example सबसे कम रहेगा, right? तो ये जो position है, this position, it is your best fit line. This position is your best fit line. मतलब यहाँ पे ये जो point है सबसे कम, वहाँ पे अगर आप check करोगे, you will have very less. I'll not share my screen. Just a minute. Okay. So what I was explaining is mean squared error 14.83 आ रहा है, तो it is over here, right? Mean squared error second line है, second line उसका mean squared error आ रहा है यहाँ पे, then third यहाँ पे. So what is your list position? सबसे कम cost function किसका है? ये point का, right? So your best fit line is this thing. Best fit line is this point, and your aim is to find the best fit line. Your main aim is of machine learning model is to find the best fit line. This is your main aim of any machine learning model. Now, if this is clear, you can let me know. If it is clear, everyone. So cost function यहाँ पे mean squared error है आपका, और first position पे you'll have over here, second position पे यहाँ पे, then likewise it will go and you'll find the best fit line. बट इसमें प्रॉब्लम क्या है कि सपोज इफ यू टेक, ये जो स्टेप है इसको बोलते हैं स्टेप साइज और लर्निंग रेट. ये जो स्टेप है कितने से कम हो रहा है, दैट इज योर लर्निंग रेट. सो इफ यू जस्ट टेक दिस ओवर हियर, तो लर्निंग रेट सपोज आपका बहुत ज्यादा है, बहुत ज्यादा है यहाँ पे, तो आप इतने स्टेप से ही कम कर सकते हैं, राइट? इतने स्टेप से ही कम कर सकते हैं, इतने स्टेप से ही कम कर सकते हैं, और आपको ये फाइंड करना है. तो विल नॉट फाइंड दिस. अगर if your learning rate is high, but if your learning rate is low, just like in previous case, तो low learning rate रहेगा तो आपका chances बहुत high है to get this point. This is your low learning rate, right? So learning rate कम हो अगर होगा तो there is a chance नहीं कि no chance, directly we can go with this, we can get this minimum cost function. But high learning rate रहेगा तो it will go like this, and it is known as overshooting. So that is what I have explained over here. Then evaluation metrics for linear regression, we are going to see this now. And assumptions we already have discussed. Multiple linear regression क्या रहता है? अगर एक ही independent variable है तो वो हो गया simple linear regression. Let's say आपके डेटा में you only have this thing. This is your square feet area. This is your price of a house. So ये क्या है? ये हो गया simple linear regression. इसका equation कैसे बनेगा? Y is equal to mx plus c, because you have only one independent variable. But let's say आपके पास बहुत सारे वेरिएबल है, 4-5 वेरिएबल है आपके डेटा में. जस्ट वो MPG केस में क्या था? We have acceleration, we have cylinder, number of cylinders, we have n number of independent variables. MPG cylinder, displacement, HP, weight, acceleration, year, origin, car type, right? So इसका इक्वेशन कैसे बनेगा? सपोज यहाँ पे कितने 1 2 3 4 5 6 7 8 इंडिपेंडेंट वेरिएबल. So you'll have y is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus so on, like mnet xnet, and then you have c. This will be your equation. तो इसको बोलते हैं मल्टीपल लीनियर रिग्रेशन. And this is what we already have discussed, right? This is what we have discussed. So let us go and check what do you mean by evaluation metrics in regression. But it's 11:59 and let's have a break for 5 minutes. We'll exactly meet somewhere around 11, 12, 6 p.m. Now, do you have any questions in the cost function in this part? Anybody have any doubts? You can ask. Yes, anyone have any questions in this? Is it clear for everyone? All right, then let's have a break for till 12:06. Yes, anyone have any questions in this? All right. So let us go with the evaluation metrics for रिग्रेशन. तो रिग्रेशन के लिए आपके पास अलग अलग इवैल्यूएशन मैट्रिक्स है, और क्लासिफिकेशन के लिए भी हैव डिफरेंट इवैल्यूएशन मैट्रिक्स. फॉर रिग्रेशन यू हैव दिस थिंग, mean, absolute error, mean squared error. Then you have सारे टाइप के एरर बेसिकली आर योर पार्ट ऑफ योर इवैल्यूएशन मैट्रिक्स फॉर रिग्रेशन. So mean absolute error, mean squared error, root mean squared error, root mean squared log error, root mean squared error, root mean squared log error, right? Apart from this you have R2 score, उसको R squared भी बोलते हैं, और adjusted R squared. So R2 score, you can call it as R2 score or R squared and adjusted R squared or R2 score, right? So mean absolute error क्या है? It's like just a error term. See, absolute means we are not considering the sign. Simple metric which calculates the absolute difference between actual and predicted value. That's all. तो साइन का आप मतलब निगेटिव रहेगा तो भी उसको पॉजिटिव ही कंसिडर करें. Then mean squared error we have seen this thing. Root mean squared error मतलब mean squared error जो रहेगा उसका square root. That's all. Root mean squared log error, nobody uses this. R2 score is important. So it tells the performance of your model, not the loss of, in an absolute sense, that how many wells did your model performs. So what is the physical significance of R2 score? It tells you about how much your independent variables are capable of predicting the dependent variable or target variable. तो तुम्हारे इंडिपेंडेंट वेरिएबल कितने कैपेबल है, कितने परसेंट कैपेबल है टू प्रेडिक्ट द टारगेट वेरिएबल. सो वहां पे एमपीजी था, राइट? बाकी सिलेंडर, देन नंबर ऑफ गियर्स, acceleration, and what about the other variable that we had? Displacement, hp, weight, displacement, hp, right? ये सारे इंडिपेंडेंट वेरिएबल कितने परसेंट कैपेबल है टू प्रेडिक्ट द target variable, to predict your mpg, mileage of a car, right? So वहां पे आपका एक्यूरेसी कितना आ रहा था? What was the accuracy? It is 82.62. So you should write 82.62% capable है तुम्हारे. It was not accuracy, it was R2 score, right? So R2 score कितना? 82.62. So your independent variable are 82.62% capable to predict the mpg of a car, right? So this is what you have for the R2 score. And बाकी most commonly used RMSC भी है. R2 score is very widely used, and sometimes you go for mean squared error. तो R2 score is just like accuracy. तो accuracy maximum चाहिए या minimum चाहिए to for the best fit model? It has to be maximum. And error terms minimum चाहिए या maximum चाहिए for the best model? एरर सबसे कम चाहिए, राइट, मिनिमम चाहिए. So this is what you have, and this is what we have for the evaluation metrics for regression. For classification, we have different evaluation metrics that we are going to study when we are going to see the classification machine learning model. So let us say accuracy, precision, recall. These are the evaluation metrics for classification. Now we'll go for next model, next machine learning model, which is your logistic regression. I'll just open this just a minute. So we'll try to understand the logistic regression now. So in this session, we are going to see what is logistic regression, why do we use it over linear regression, what is logistic function, what is cost function in linear regression, what is gradient descent optimization. Gradient descent, though, we already have discussed. Cost function also it is discussed. So let us say आपको क्लासिफिकेशन मॉडल है. What do you mean by classification model? What is classification? When we say our machine learning model as classification, when do we say that? When your target variable is when your target variable is categorical in nature. When your target variable is categorical, means it is in the form of categories like text data. अगर टारगेट वेरिएबल आपका टेक्स्ट है, जस्ट लाइक फॉर एन एग्जांपल ट्रू और फॉल्स आपके टारगेट वेरिएबल के आउटपुट है, या फिर यस और नो आउटपुट है, या फिर क्लास 0 क्लास 1 आउटपुट है. सो मोस्ट प्रोबेबली अगर आपका अगर आपका टारगेट वेरिएबल के दो क्लासेस हैं, इट इज नोन एज बाइनरी टारगेट वेरिएबल, बाइनरी आउटपुट. दो मतलब यहाँ पे दो है ना, ट्रू फॉल्स यस नो क्लास 0 क्लास 1. सो एट दैट टाइम इट इज this logistic regression is used. It is known as dichotomous. So let me take this just a minute. Now let us take a figure for this. सो सपोज आपका क्लासिफिकेशन मॉडल के लिए इफ यू fit the linear regression for classification model. So let us take this image. यहाँ पे what they have done is ये आपका linear regression है. तो ये डेटा के ऊपर मतलब क्लासिफिकेशन डेटा के ऊपर यू हैव फिटेड द लीनियर रिग्रेशन मॉडल एंड दिस इज योर बेस्ट फिट लाइन. तो ये जो लाइन है दिस इज योर बेस्ट फिट लाइन, दिस लाइन ग्रीन लाइन. एंड एज यू कैन सी कि ये बेस्ट फिट लाइन इफ आई ड्रॉ इट लाइक दिस और इफ आई ड्रॉ इट लाइक दिस और इफ आई ड्रॉ इट लाइक दिस इट इज नॉट, इट विल नॉट कवर द एंटायर डेटा पॉइंट. ये सारे डेटा पॉइंट्स कवर नहीं कर रही हो, राइट? तो ये फर्स्ट ड्रॉबैक है आपके लीनियर इफ यू फिट द लीनियर रिग्रेशन मॉडल ऑन क्लासिफिकेशन. सेकंड क्या है, अगर इफ यू हैव आउटलायर्स, सेकंड ड्रॉबैक इज इफ यू हैव आउटलायर्स. जस्ट से कि अगर आपके पास आउटलायर है, ये आपका आउटलायर है, सपोज आपका बेस्ट फिट लाइन ऐसा था पहले या फिर ऐसा था, बट इफ यू हैव आउटलायर नाउ, तो ये आउटलायर की वजह से आपका बेस्ट फिट लाइन टोटली शिफ्ट हो रहा है, राइट? ऐसा बिकॉज ऑफ आउटलायर्स your best fit line is totally shifting to the other side, to the outlier side. Right? So second drawback is if you have outliers in your classification model, you cannot fit the linear regression. Now what is the solution for this? We use logistic function. We use logistic function. Why do we use logistic function? Because ये logistic function क्या करता है? देखो, linear regression अगर आपका ऐसा लाइन है, तो logistic regression what it does is ये डेटा के ऊपर आप लीनियर रिग्रेशन फिट कर रहे हो तो सारे डेटा पॉइंट्स कवर नहीं हो रहे, राइट? सारे डेटा पॉइंट्स कवर नहीं हो रहे यहाँ पे. तो लॉजिक रिग्रेशन और लॉजिट फंक्शन या सिग्मॉइड फंक्शन भी बोलते हैं उसको. व्हाट इट डज इज इट विल इट इज जस्ट लाइक योर एस शेप कर्व, एस शेप्ड कर्व. तो ये लॉजिस्टिक फंक्शन या फिर सिग्मॉइड फंक्शन, इसको क्या बोलते हैं? एस शेप्ड कर्व. उसका फॉर्मूला अगर आप देखोगे तो वी function. What we do is we feed our data into this function. ये function आपको ऐसा लाइन मतलब ऐसा ग्राफ आउटपुट में देती है and it will try to cover the maximum data points, right? तो ये straight fit line को we are converting it into S shape curve by using this logistic function. तो यही आपका logistic function है and that is what it is known as your logic regression, right? So difference between linear regression logic regression क्या है कि लीनियर रिग्रेशन आप सिर्फ कंटिन्यूस वेरिएबल या फिर नंबर प्रेडिक्ट करना है वो जगह पे ही यूज कर सकते हो. एंड लॉजिक रिग्रेशन यू कैन यूज इट फॉर क्लासिफिकेशन, राइट? So this is what we have, and then what is our cost function over here? ये लॉजिस्टिक फंक्शन है which we use. ये क्या करता है? It converts into probability. आपका डेटा पॉइंट है उसका प्रोबेबिलिटी मतलब डेटा को it converts into probability from 0 to 1. तो सारे डेटा पॉइंट्स प्रोबेबिलिटी में कन्वर्ट होगी, क्लास 1 क्लास 0, तो कुछ कुछ डेटा पॉइंट की प्रोबेबिलिटी 0.8 रहेगी, कुछ की रहे वी हैव some data points whose probability would be 0.3, तो we set the threshold 0.5. अगर डेटा की probability greater than 0.5 है, if the probability is greater than 0.5, so वो क्लास 1 में जाएगा, यहाँ पे क्लास 1 प्रेडिक्शन में जाएगा over here. And if the probability less than 0.5, 0.5 से कम है, तो that will be of class 0. तो ऐसे वो prediction देता है, ऐसे we use the logistic function. See, if the output is greater than 0.5, it is class 1. Output is less than 0.5, it is class 0. And this is what your cost function is. Linear regression का cost function ऐसा था आपका, but logic regression का you have this thing. So suppose you are at this position, तो आपको लोकल मिनिमा ही मिलेगा, राइट? मतलब आप यहाँ पे हो, सपोज जस्ट लाइक योर स्मॉल पार्ट ऑफ दिस, ये जो है इसका जूम पार्ट है, और ये लीनियर रिग्रेशन का है. लॉजिक रिग्रेशन में क्या हो सकता है कि यू हैव अ ग्लोबल मिनिमा. सबसे मिनिमम कॉस्ट फंक्शन किसका है? ये पॉइंट का है, ना कि ये पॉइंट. बट आपका डेटा यहाँ पे ही रिवॉल्व कर रहा है, आपका कॉस्ट फंक्शन रिडक्शन जो मॉडल. तो आप यहाँ पे यू कैन नॉट अचीव दिस पोजिशन, right? The problem here is cost function will give you the local minima all the time. Local minima ही देगा वो, which is a big problem because then we'll miss out the global minima and our error will increase. सबसे कम error कहाँ पे है? Global minima पे, ना कि local minima पे. So we use which cost function over here for this? Linear regression में mean squared error use कर रहे थे cost function, mean squared error. बट यहाँ पे ये पोजीशन पे we use log loss. Just remember we use log loss for this. Now this is what we have for the this thing. So log loss अगर आप देखोगे we have a log loss cost function. देखो ये पॉइंट है, and this is a log loss cost function which is derived from maximum likelihood estimation. इसके लिए अलग mathematics है, but it is not required for you as at this point of time. So ये है mathematics इसके पीछे. Right? So this is what we have for the logistic regression. इसमें अपन लोगों ने ये सारे points discuss किए. These are the points that we have discussed. Now we'll take a data and we'll try to fit the logistic regression on that data. Let us create a new folder. So, logistic regression. Let us upload the data. Diabetes. Let us create a new notebook. Let's rename this as the logistic regression. And what is the first step? We import the necessary libraries. Importing pandas as feeding. Import numpy as np. Import matplotlib .pyplot as plt from sklearn .model underscore selection. Import train underscore test underscore split from sklearn dot linear underscore model. Import train underscore test underscore split. Linear underscore model, we have logistic regression. So if you search logistic regression package, you will get the package name over there, right? Go to the official documentation of sklearn, and this will be your package. So वही package यहाँ पे import किया logistic regression. I will read the data. df is equal to pd dot read underscore csv and file. Let's check head of the data. So आपका what is your problem statement over here? You have data in which these are the records that you have: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, if age and outcome. तो outcome अगर 1 है, it means person has diabetes. And if the outcome is 0, it means person does not have diabetes. This is your problem statement. Now you have to build logistic regression machine learning model which will predict the outcome by using these independent variables. By using these independent variables. So how to go with this? We have same procedure as we have done in the linear regression model. First is EDA, which is known as exploratory data analysis, right? In EDA, what do? You go with the info You check the null values, is n a dot sum. So we do not have any null values, right? Then what do? We go with the describe. We find the skewness, kurtosis. Then right after this, what do? We will go with the box plot, plt dot figure. Figure size is equal to 20, 12. df dot box plot, vertical is equal to false. Now we'll write on df. To remove the outlier, we have to create the function. So same function we can use. I'll just take this out. We'll use the same function over here because everything will be same. But for this thing, here we have removed the origin, MPG and car name, because car name, it is categorical. MPG was your target variable. Origin we do not require that because origin में आपके पास outlier नहीं थे already, origin column. So in this thing, for column in df dot drop, you want to drop outcome from axis is equal to 1 dot columns. Lower whisker comma upper whisker is equal to remove outlier function df of column, then df of column is equal to np dot where df of column is greater than upper whisker comma replace with upper whisker इसको df of column. Same thing, I'm not doing anything new. I'm just using this thing, right? Same, I can copy it. Let's take this and let us paste it over here. df dot box plot, figure size is equal to 20, 12, vertical is equal to false. Now we have train test split. इसके लिए क्या करते हैं, x and y में आपका डेटा डिवाइड करते हैं. x में क्या रहता है, you have all the independent variable in x. Outcome from x is equal to 1. y में you have df of outcome. Then x underscore train, x underscore test, y underscore train, y underscore test is equal to train test split package name x comma y comma test underscore size is equal to 0.3 comma random underscore state is equal to 40. Let's take 40. X train dot a. तो x train में क्या है आपका, मतलब x में क्या है basically, you have all the independent variables, right? And y में क्या रहता है, you have all the target variable. तो target variable हमेशा एक ही रहता है. Now this is how you do the trend test split. Random set मैंने 40 लिया है, you can take any value. Test size 0.3 है, मतलब 70% डेटा किसमें, आपका ट्रेनिंग में. तो if you check the shape of X train and if you just check 70% of 768, it will be 537, right? Or if you just take 30% of 768, it will be 230. So X test dot shape is 230. Now we have model building. What is the first step? Model object creation. What is the second step? Model fitting. What is the third step? Model prediction. And what is the fourth step? Model evaluation. If you run this, you can write the model is equal to logistic regression, which is your package name. Second step क्या है? Model fitting. So model dot fit x underscore train y underscore train. What we do is we write down, we always fit it on x train and y train. Third step. What is your third step? Model. Step number 3. Model prediction. Y pred is equal to model dot predict x underscore test. And what is the step number 4? It is model evaluation. In this thing, we need evaluation metrics or classification, because logistic regression is your classification type. तो classification के लिए we have accuracy, right? Confusion metrics. We'll see this thing, but as of now, let's go for accuracy score. So what I'll do is I'll just take accuracy score package name and I'm going to paste it over here. So I'll just copy this. I'm going to paste it over here. Model evaluation, accuracy score, y test, comma y pred. So 73.51 accuracy आपकी, right? So this is what we have for the model building. ये हो गया logistic regression का model building. You can go through this. If you have any questions, you can ask. So I'll just share this tab and if you have any questions in this. Anybody with any doubts? Confusion matrix. Third is your precision. Fourth is your recall. Fifth is your F1 score. ROC uses code. Yes, so we'll discuss this afterwards, and we'll discuss how to increase the accuracy as well. How to increase the accuracy. So apart from this, anyone have any questions in this? You can ask. I'm waiting for your questions. Yes, Prashant, Vinay, Gautam, Piyanshu, Prashant, Vinay, Vaibhav, and Atul. Is it clear for everyone? All right, so this is new topic. This thing will require half an hour to discuss this thing, these two topics. We'll discuss it in tomorrow's session. I'll just give this thing on your drive. Machine learning. Just create new folder. Logistic regression. Right. So I've given this thing on your drive. All right. So we can stop here for the day. Tomorrow we'll continue with the next part. All right then. Thank you. Happy learning. Bye. Assignments कब मिलेगी? Next week में I'll prepare. I'll give you assignments. ठीक है then. All right. Thank you. Bye.